You know that feeling, right? You're staring at a constructor with what feels like a dozen parameters, and your eyes just start to glaze over? Well, today, we're going to demystify the elegant solution to that exact chaos, the builder design pattern, straight from the classic Gang of Four book. Let's jump right in.
Oh yeah, we have all been here. You're just trying to create a simple object, but you're looking at a constructor that just keeps on going and going. You're literally counting commas, trying to remember if age came before email, and just tossing in null for all the things you don't care about right now. It's not just messy, it's a recipe for disaster.
You look at that single line of code, and a little voice in your head just says, "Come on, there has to be a better way than this. A cleaner, safer, more readable way to put these complex objects together." And guess what? You're absolutely right. There is.
So here's our roadmap. First, we'll really break down why constructors can be such a problem. Then, we'll introduce the step-by-step solution that the builder pattern offers. After that, we'll look at the anatomy of the pattern, see it in action with some code, and finally, figure out exactly when it's the right tool for the job.
Okay, so let's really dig into that core issue. Why do constructors, which are so fundamental to programming, suddenly become our enemy when objects get even a little bit complicated?
Well, this problem usually forces us down one of two pretty bad roads. On one side, you've got what's called telescoping constructors. It's this wobbly Jenga tower of constructor overloads, each one adding just one more parameter. It becomes an absolute nightmare to maintain. And on the other side, you have that single, monster constructor, leaving this trail of confusing null values. Neither way is good. Neither way scales.
And this is exactly where the builder pattern comes into the picture. It offers a totally different way of thinking about object creation, getting us away from that messy all-or-nothing approach of a constructor.
The core idea? It's actually brilliantly simple. What if, instead of trying to cram all the information into one giant error-prone function call, we could just build the object gradually, piece by piece, only setting the parts we actually need?
Now, the official definition from the book sounds a little academic, but it holds the key. Separate the construction of a complex object from its representation. So what does that really mean? It means the how you build something is now separate from the what you end up with. The process itself becomes this reusable blueprint that can create totally different things.
Think about building a house for a second. The steps are pretty much always the same, right? You lay a foundation, you build the walls, you add a roof, you install the doors. But by following those exact same steps, you could build a tiny cottage or a fortified bunker with an armored door. The construction process stays the same, but the final thing, the representation, is completely different. That's the real power here.
Okay, so now that we get the big idea, let's pop the hood and look at the formal structure. There are 4 key players that work together to make this all happen. This here is the classic blueprint. It's kind of like ordering a pizza. The director is you, the customer, who knows what you want. The builder is like the menu. It defines all the possible steps. You can add dough, add sauce, add toppings. The concrete builder is the actual chef, the one who knows how to make a specific pizza, like a margarita. And the product? Well, that's the delicious pizza you get at the end.
So to bring that back to our house analogy, the builder is the master blueprint that says you need to be able to build walls and build roof. The concrete builder is the actual construction crew, the specialists who know how to build with brick versus steel. The director is the project manager, the one making sure everything happens in the right order. And of course, the product is the finished house itself.
All right, enough theory. Let's see how this all comes together in a practical workflow. We'll look at how these parts all collaborate, and more importantly, what this looks like in modern code that you'd actually write.
This diagram shows the whole dance perfectly. The client starts everything off by picking a specific builder, maybe the luxury house builder. Then they hand that expert crew over to the director. The director's like the foreman. They just call out the generic steps. Build part A. Now build part B. The concrete builder on the ground knows exactly how to execute those steps to make the luxury version. And finally, the client just asks for the keys to the finished product.
And in today's code, this often shows up as this beautiful, fluent API. Just look at how clean that is. Each method call sets up one piece of the object, and then, this is the magic part, it returns the builder itself. That lets us chain them all together. It reads like a plain English sentence. No null placeholders, no confusing order of parameters. You just set what you need, call build, and you're done.
And here we go. This is the big aha moment. On the left, you have that cryptic mess. Which null is which? Is that a bug waiting to happen? You bet it is. On the right, you have a clear, self-documenting story. It tells you exactly what it's doing. There's zero confusion. The leap forward in clarity and safety is just massive.
So you're probably thinking, this is amazing, I'm going to use it for everything. But hold on. Like any pattern, it's not a silver bullet. Knowing its proper time and place is absolutely key.
The original book gives us two really clear signposts for when to reach for a builder. First, use it when the process of creating your object is pretty involved and you want to keep that process separate from the object's parts. And second, use it when that same construction process needs to be able to create different kinds of things. Remember our house builder making a cottage or a bunker? If you need that kind of flexibility, the builder is definitely your friend.
Now let's talk trade-offs, because there are always trade-offs. The pros are huge. It makes your code way more readable, gives you precise control over construction, and neatly tucks away all the messy setup logic. But on the other side of the coin, you do have to write an extra class, the builder itself. For really simple objects, that can definitely feel like overkill, and it's certainly more typing than a simple constructor.
Here's the cool part. You've probably been using this pattern for years without even realizing it. The book talks about classic examples like document converters, but today, it's everywhere. Building HTTP requests in an API client. That's a builder. Constructing a complex database query. That's a builder. Even something as common as Java's string builder uses this exact idea of building a complex thing, in this case a string, step by step.
And now for a quick pro tip. Remember the director, our project manager? In that classic pattern, it's a whole separate class. But honestly, in most modern Fluent builders, you are the director. The client code itself calls the methods in the right order, directing the construction process. This really streamlines the pattern and makes it even easier to use in practice.
So, let's wrap it up. The builder pattern takes the utter chaos of complex constructors and replaces it with a clean, methodical, step-by-step process. It separates the how from the what, which gives us code that's more readable, way easier to maintain, and a heck of a lot more flexible. It is a seriously powerful tool for taming complexity. So the only question left is, now that you know how to use it, what will you build?